follow up the discovery by the TESS satellite of candidate transiting planets. We relied heavily on the experience with Kepler and K2. So I'm going to subject you to my history of what we learned from Kepler and K2. But I didn't want that to be K2. That's what I wanted. So this history starts with the first transiting planet, HD 209458, two back-to-back papers in the APJ letters in January 2000. That's actually a very important event because we were just in the process of submitting the final proposal after the concept study for Kepler, a month after those two papers came out. And we like to think that it had an impact on the selection of the Kepler mission because, lo and behold, there were transiting planets that we could hope to observe, and lots of them with the unexpectedly short periods, 3.5 days in the case of 209458. So the Kepler mission was selected for implementation. It was a Christmas present in 2001, launched on my mother's birthday in 2009. And there was reluctance by mission managers to release the data. There was a long proprietary period because of that paranoia that there might be premature announcements that would later be shown to be false. And that led to pushback from the community, and the reaction was to shorten the proprietary period, and that convinced us, if we didn't need to know with Kepler, also with K2, that we should have no proprietary period with TESS. And there were opportunities for community members to join the Kepler mission by submission of proposals to a solicitation from NASA. And there was encouragement of community involvement in working groups that could join together with the Kepler team. And all three of these strategies we adopted for the TESS mission. And then we get to K2. Now we get to K2. You have to massage your sweat? Yes. You don't want to hit it too hard. So you're along with the story about the second of 4 reaction wheels failing in May 2013. And a couple of smart young engineers at Ball Brothers in Boulder figured out a way to track along the ecliptic. We couldn't track in the original Kepler field the fine tracking that was needed for the terrific precision, photometric precision that Kepler was giving. And that would require anti-solar pointings along the ecliptic and use thrusters for corrections. It was an unstable equilibrium that would gradually start drifting off, and you'd have to kick it back with the thrusters. And there was minimal funding, and therefore there was no proprietary period, and minimal funding, and minimal support of the science team. And so the reaction was that teams grabbed the lowest hanging fruit and rushed papers to publication, often half-baked papers, often duplicating other papers. Chaz called it the Wild West. And after 18 campaigns of 3 months each, the thruster fuel ran out in summer of 2018, and miraculously, TESS launched just in time to start science operations in summer of 2018. So we brought a lot of the expertise that we had learned from Kepler and K2 into the TESS follow-up observing program working group. So our goals, get the best science. Well, we initially emphasized exoplanet science, but of course we want the best science from all kinds of astrophysics. And we certainly wanted to avoid the Wild West. And we wanted to meet the level 1 science requirements, 50 planets smaller than 4 Earth radii, with masses and radii. And we wanted to harness the resources around the world to get those observations. And we wanted to encourage people to work together, so communication and coordination would be important, especially in publications, to minimize duplication of effort, get high-quality papers. And personally, I wanted to promote and protect participation by early career researchers. And at this point, I want to acknowledge the critical role played by ExoFOP tests at the NASA Exoplanet Science Institute. That is an effort to bring together and serve all the useful information about the results for test objects of interest, the candidate transiting planets. It has the basic information for every star in the test input catalog, 1.7 billion roles, and individual pages for the candidates, not just from the mission, the test objects of interest, but also the community objects of interest. And eventually includes all of the Kepler objects of interest as K2 candidates so that you can match up the data, for example, to improve ephemerides. And it's a repository for all of the TESScon3 working group observations. And most of those observations are posted without a proprietary period, although in some cases where it makes sense, you can ask for a 1-year proprietary period. And it supports the facility for entering observing notes and even interpretation, discussion of what kind of configuration a particular TOI might be. And perhaps most importantly, it was responsive to users. The equivalent thing that was done for Kepler was designed from the top down. The ExoFOP test was built from the grassroots up to respond to what everybody was hoping they could get. And I should also note there's an important role for the STSCI providing through MAST the test data products themselves. But the two facilities complement each other very well, if you think of it. So how's my time going? Well, I'll go through this very quickly. Most of you have seen this before. I checked the list of people attending the conference and counted more than 90 members of the TESS Follow-Up Observing Program Working Group. So I'm preaching a little bit to some of the choir. SG1 is the largest effort by several measures, led by Karen Collins in the front row here. A lot of the work is to identify eclipsing binaries that are contaminating the test photometry because the pixels are so big, 21 arc seconds. So seeing limited photometry can get down to 1 or 2 arc seconds. It's nice if you can confirm if a transit is on the target star and that better seeing resolution. But of course, the ground-based photometry won't have the limiting precision that you can get from space. So you can confirm that the events are on from a giant planet or on the target, but not for the really small objects of interest, companions. And quite remarkably, Karen and now Crystal, working with Karen, review all of the light curves that are submitted by the community. And not every community member does a really good job of it, but a good job gets ending up on ExoFop because of that review. Quite amazing. Second subgroup is recon spectroscopy, led by Sam, 2 minutes. And 2 more. Oh, we skipped over something. Well, you just have to imagine. There's additional working groups, single transit planet candidates, led by Deanna, and transiting brown dwarfs, led by Theron. We're going to have a special session on Wednesday in the afternoon on the work going on now, and that's a new working group just in the last year. 543 confirmed test planets in the exoplanet archive. Compare that to 322 from Kepler, mostly fainter, much harder for follow-up. 106 from K2. These are the prime targets. The TESS confirmed planets are the prime targets for JWST because they tend to be brighter. Of course, it's the smaller targets that you don't get from the ground-based bright targets. And many papers led by early career researchers. I like to think that we're training we see the training of a whole new generation of exoplanet experts. And I would call it a successful social experiment in widespread collaboration. It's amazing how well the community worldwide has bought into this effort to get the best results, the highest quality results, and get proper credit to people that deserve it. So I'm going to end with a couple of figures prepared yesterday by Sam, so they're obviously up to date. Between August 2021, which is not only the end of the prime mission in terms of meeting level 1 requirement, 2 years on the sky and a year to get our stuff together. And that's 65 test planets published. And on the right, you see right now, 146. Isn't that interesting? It's every 3 years we're getting about 65. The quantity, will this go on forever? Well, maybe not. So I'll let you gaze at those results, which I find quite remarkable, while we go into questions.